Hello from AI Sciences and welcome to Mastering Python for Data Science. This is video 2. In previous video we saw that why Python is really important, why that's a huge language, why that's a beautiful language. We also saw that although there are several IDEs available, but particularly for data science, Jupyter Notebook is much more popular than the other. Then we saw how to install Python using Anaconda, how to launch Jupyter Notebook on Windows, on Ubuntu, on Mac OS, and then we directly jump to variables and operators, comparisons, Boolean data types, certain important functions or useful functions including round, div mode, is instance, power input. We saw string class. We actually saw a little bit of string, what that is. We saw certain how to index different strings. We also saw some important functions in string, although we could not go through all the functions, but we saw some of the functions at least of string class. Then we jumped towards data structures. We saw list, tuple, set, dictionary, and we saw just some important similarities and differences in these. One thing that we were calling set update function last time, and we were not giving these curly brackets inside, and we were getting an error on Jupyter Notebook. So basically, if you remove last time we were calling this from Jupyter Notebook without curly brackets inside, and we were getting an error. So the exact code or the bug fixed code is, if you want to call the update function on S, if you want to insert multiple items in the set, if you want to add multiple items in the set, you have to give the multiple items in terms of set. We will see an example of this today, but that was a bug last time that we found in our coding. So then we saw if conditions, and we saw the structure if, elif, and else. We saw the shorthand notation, and here we ended last time. Today we will start by first giving you the exact code that we were getting error on, the update function on set, and then we will be moving on towards some more. We will talk more about if conditions, we will talk about loops, functions, module, and then we will be briefly discussing some of the very important packages in data science. One is NumPy, one is Pandas, and we will touch just Matplotlib as well. So I mean, stay with us throughout this video. You are going to learn a lot in this video, as well as like in the previous video, you're going to learn much more in this video, because this video will be completing the content from the previous video. So first, let's see the set update. Let's say this set is S is simply let's say 1, 2, 23, and 49, and ABC. Let's say that's a set, and then we just call update function set update, and then we insert multiple elements. Let's say 45, and then we insert 45, and then we insert 45, 45.6, let's say. And now if you see S will be containing the previous elements like 1, 23, 49, ABC, and the new elements 45 as a string, 45 as an integer element, and 45.6 as a floating point number. So we were getting an error because we were not mentioning these curly brackets in the last video. So that's a fix to that thing. So today we are going to talk about the nested if inside if. So for example, let's say you call the input function enter a number, and let's say you are expecting an integer number, and you typecast the string into integer, and then you check if x is larger than 10, then you should print your number is above 10. See, this whole thing, I mean this whole block, this is actually body of the if. We call that body of if. So that is body of this if condition. So this print function, this if condition, this all that is in the body of this outer if. Now the print your number is above 10. Then inside the if, in the body of the if condition, we can have an other check. if inside the if, and that is called nested if. And you can have this nested structure, I mean very deep nested structure, depending upon your logic. You can have that. I mean Python allows you to have that. So if x is really larger than 10, then you are inside this red block, and once you're inside that red block, you can make more decisions. You can check for more decisions. For example, if x is larger than 20, then print it's also above than 20. Otherwise, else print but not above than 20. So if this is the top if this is the if inside the if, and that is called nested if. You can have another if inside that if, and that is the third I mean nested if inside, and you can have this structure very deep inside. So let us just see how this nested if works. Let us just code it on the notebook and see how it really works. So let me just let's say a equals or x equals int input enter a number, and then we say, okay, if x is larger than 10, then print greater than 10, then print this thing. And further if x is greater than 20 as well, then print greater than 20 also. Otherwise, else. Now see, this else should be here. Else print but not greater than 20. So if we run this, we will be asked for a number. Let's say the number is 11. Let's say the number is 11, and the result is it is greater than 10 but not greater than 20. Similarly, if we run this again and we give the number, let's say 22, we will be saying, okay, it is greater than 20 and greater than 10 and greater than 20 also. So this if is inside that if, and so on. We can have one more if inside, and then one more if inside, and so on. So that is nested if. Further, it is important to note that if we place this else in the alignment of this if, remember this indentation is very, very important. The body of if condition starts from this indented block, and then the body of this particular if starts from this indented block. Now, if this else is in the alignment of this if, then this else will be considered with this particular if. However, if the same else just moved back here and is aligned by this if, as shown in the right side here, then this else will not be considered an else part of this if rather than this if. So basically, this is the alignment, this is the indentation that defines which structure belongs to which block. So for example, this else structure belongs to this if rather than this if. So let's see, for example, the consequence of this in Jupyter Notebook. For example, if we just copy this code to the next cell, just so that this also stays there in the notebook, and we just place this else here. And remember, if we place this else here, then the body of that else will start from here. It's a complete alignment structure. Now this else, this particular else, is else of this condition. It is no longer else of this condition. So if x is larger than 10, then you'll be here. If x is not larger than 10, then you'll be here. Straightforward. And there is no else part for this if condition. Although it is a nested if, but without an else part. So let's run it. So we have, let's say we have 10, let's say 11. So greater than 10, and that's it, because you ended up here and then you did not end in this, and that's it. For example, if we run this again and give a number, let's say 22, then 22 is larger than 10, yes, you landed here. Then 22 is larger than 20, you landed here, and you are done. But if number is smaller than 10, for example, let's say you give number 4, then you land it in this part, because if x is larger than 10, if that is false, then you go to else part, and that's the else part. So be careful about the alignment in Python, because this alignment or indentation, this defines the whole structure. Okay, the same thing is achievable. I mean, the nested if you want to achieve this nested if x larger than 10, then inside x larger than 20, this is the same thing as saying that if x is larger than 10, as well as, or and, that's a keyword, and x is larger than 20, then print this particular block. This is the whole block for this particular if condition. Else, if x is larger than 10 and x is larger than 20, if this condition is false, which means either x is smaller than 10 or equal to 10, or x is I mean, either x is smaller than 10, or this condition is redundant, because if x is larger than 20, then it must be larger than 10. So we should not be writing this condition, because this is not playing a role at all. If x is larger than 20, then it is larger than 10, either way. So if x is larger than 20, and so let me call this as if x is larger than 20 and less than, if x is larger than 10 and less than 20, then your number is above 10, but not 20. Then the second condition is if x is larger than 10 and if x is larger than 10 and x is larger than this thing. I mean, the whole point of saying is that the nested if structure can be achieved by the combination of ands and ors. So you can have ands and ors combined together, and that will give you a look and feel of the complete nested if structure. Let's code it, the similar kind of code in Python. Let's see, in Jupyter Notebook. So let's say again, let me copy that code just write, for example, here. X is input again. If x is larger than 10 and x is smaller than 20, if x is larger than 10 and smaller than 20, then you do what? Then it's larger than 10 and smaller than 20, for example. Maybe we have an elif x is larger than 10 and x is larger than 10, as well as it is larger than 20, then we will say okay, print larger than 10 and larger than 20. Maybe another else if x is smaller than 10 and x is larger than x is smaller than 20, then we will say okay, print x is smaller than 10 and smaller than 20. Else maybe we should we are confused, maybe. So you can see that, I mean, this and, there is an and, there is an or, there is a not, these kind of things. So this can happen. I mean, you can apply these ands and ors, combinations of these, to just achieve the nested structure, but sometimes the nested structure is really readable and important, and the way you want, you should proceed in that way. So syntax error, there is. So we missed a colon there, so that should be an error. Okay, enter a number. The number we are going to enter is, let's say the number we enter is just 15, and see where we land. It's larger than 10 but smaller than 20. One other trick is that, for example, if you want to write this condition and then you want to say whatever that condition is, reverse of that. For example, if you want x is larger than 10 and x is smaller than 20, then you want to print that. And if this doesn't happen, if this doesn't happen and whatever else has happened, then you want to do something else. For example, just for example, let's say we do that and we just move back and say if this, then this, else if not, else if not this, else if not this, then this is exactly the else part. You see, if this happens, then do that. If this doesn't happen, which means we can write else here, or we can write else if not this, then we can write this, for example. So this else if not, this not means if this doesn't happen. So let's see what happens. For example, the number is 45, and 45 means oh, neither this happened nor that happened. So 45 is why could we not land in this? Why could we not land in this? Because if x is larger than 10 and smaller than 20, then we are here. Otherwise, we should be here if this doesn't happen. So if x is 45, what happens? Why we have not landed here, and why we have not landed here as well? What happens? So let's see. Let's see the bit by bit details. What happened? X is 45. So 45 is larger than 10. Correct. That's true. That returns true. 45 is smaller than 20. That's false. And true and false is false. So we are here. Then so this is x is larger than 10. That is x is larger than 10. That is true, and that is false. Oh, we mistakenly have written this thing here. That's the problem. We should have written this thing. Now this becomes an else, proper else. If this doesn't happen, then else this will happen. So we were just giving a wrong thing here. Okay, let's do it again. So 45. Okay, we go to else part. So that's it. I mean, that's beautiful. So next we move towards loops. I mean, that's another control flow structure that is very, very important, and you should be knowing this. A loop is just, I mean, multiple iterations. There are two types of loops in Python. One is while loop, another loop is a for loop that we will see shortly. But most importantly, a loop actually is a shorthand of writing a lot of instructions that are going to be repeated. I mean, maybe you want to print, let's say, all the numbers till a particular number. You have to write this print statement again and again and again. So this while will allow you a structure that is going to be repeated. You can write that whole structure that is called a body of the loop. You can write that whole structure inside the loop, and then this will be repeated until a number of instructions. Then the logic will follow. For example, if you see n is some input, I is 1. If as long as this condition is true, you will be diving into the body of the loop. And whenever you are in the body of the loop, consider just you are just in a plain instruction world. So for example, once you are in the body, you are going to print I, whatever the I is, and you are going to increment I with 1. And then what happens once you are exiting or you actually executed the last instruction of the loop body, then you go and check the instruction again. If the instruction is true, you are landing again in the loop body, and you will go through whole the loop body. And then once you are done with the last instruction inside the loop body, this print instruction is not in the loop body. Then you will go again, you will check if this condition, as long as this condition is true, you will be executing the loop body again and again. And what will happen is this kind of block, this particular block, including this print statement and this increment in I, this is going to be repeated again and again and again until the n is reached. So let's see an example of this in Jupyter. Let's see. So for example, let's say you call n equals int input, enter a number, let's say, and then we say I equals 1. This I can be any counter while this I is less than n, do something, and that something is this whole body. I mean, print I, then print I am inside the loop, and then just increment I plus equals 1. Now the whole thing, I mean whole this block is defining the body of the loop as long as you are aligned with these structure. Once you go back, if you not if your indentation is different, then this statement, for example, is not inside the body of the loop. So let's see. So for example, if I enter 10, what will happen? Let's see before running this what will happen. I will, at the very beginning, I will be 1. 1 is smaller than 10, so it will print 1. It will print this instruction, and I will be incremented by 1, and so I will become 2. Next time I will be 2. 2 is smaller than 10. Yes, you will again dive in. You will print 2 and then print this statement, and then I will be incremented and get 3. Now 3 is smaller than 10. You will go again and again and again until once when I will be 9, and you will go inside, and I will be incremented and becomes 10, and then 10 is smaller than 10 becomes false. Then you go outside the loop and you will go to this particular statement, and the loop ends there. So let's see. So that's the output. Which makes sense. I'm in 1, I'm inside the loop. 2, I'm inside the loop. 3, I'm inside the loop, and so on. And this loop goes till 9, and then the loop finishes. Yeah. So that's the look and feel of the loop while loop. Again, inside the body of the loop, you can have any kind of complex kind of structure, or I mean decision making and everything going inside the loop. For example, this particular loop is printing all the even numbers. If a particular number is even, it is divisible by 2, then print it, otherwise pass. This pass statement actually is an indicator that do nothing. If this condition holds, if this condition is true, then go to this body. If this condition is false, then do nothing and move on. So if it will print all the even numbers till n is reached. So let's see. For example, we can have if I remainder 2 equals to 0, then print I, not otherwise, else just pass, do nothing, and that's it. And this should continue. So this whole thing is the body of the loop. And that statement is not inside the loop. So it will print all the even numbers till n, and whenever this condition is false, you're diving into else part, and this pass statement is just an indicator that do nothing. We may just omit the else and this. I mean, deleting these two statements still, I mean, has the same logic, everything is same, but I just want to introduce this pass statement that actually is an indication of doing nothing. So here we move in and we write, let's say n is 10, and the result is 2, 4, 6, 8, and then done. Yeah. Okay, so a break statement, when you encounter a break statement, that means, for example, if inside the loop, wherever you find a break statement, that means exit the loop immediately. So for example, if you encounter this particular statement, which is the break statement, if you encounter this statement anywhere inside the loop, that means exit the loop immediately. So for example, whenever this break will be encountered, everything will stop, and you will directly jump to the statement that is outside the loop. Break means that. Continue statement means if you encounter a continue statement in a loop, then whatever statements that are coming after the continue statement, and those statements are inside the loop body, they will be omitted. Which means continue means whenever you encounter continue, just go to the next iteration. Just go to the next iteration and skip the upcoming statements, even if those statements are inside the loop. So that is about break and continue. So let's have a quick example of break and continue as well. Yeah, if I is this, then print this, and then just break. Else, let's omit this. If do this, otherwise that, and here we say continue, and then we say I am forgotten, which means after continue, the body of the loop is not going to execute. So that means this statement is not going to execute whatsoever. So because after continue, the loop will directly go to the next iteration by checking the condition and going inside and doing everything again. So let's see. So now let me print, let's say 10. What happens is when I was 1, it doesn't go inside the loop. It doesn't go inside the statement, and it increments I, and then it continued, which means it does not print this one, and then it back to this. When I was 2, remainder 2 is 0, it prints this, which is 2, and then it encounters a break statement. Break means exit the loop. Once you are outside the loop, you print this. So that's break and continue. Then we have these for loops. For example, that's again the kind of same thing as a while loop. While this while loop is checking some condition, this for loop is basically iterating over normally a list or a range or something. So this is one kind of syntax of for loop. Let's say we have an empty list, and then for I in this range. This range is an iterator. It gives the numbers 1 by 1 till 10, but not including 10. So it starts from 0, it increments 1 by 1 and go till 10, and then this is the body of the loop. So let's say we want to just fill this list by all the powers of 2. Here I have all the squares, for example, the square of 0, square of 1, square of 2, and so on. So this for will work in a what way? So that's the syntax of for. You can use while loop, you can use for loop, either way, but one might be more feasible in certain situation than the other. So for I in range, let's say 5, which means start from 0, then 1, 2, 3, 4, and then stop. 5 itself is not included. Then print I maybe, and then list dot append. What do you need? What do you want to append? The square of or the power 2 of I, and that's it. And once you are done, maybe you need to print that I'm done. So you can see this, and if you see, so that's which is printed. If you want to see the list, L right now is this, because 0 square is 0, 1 square is 1, 4 square is a 2 square is 4, 3 square is 9, and this is so. So see how quickly we were able to populate this list using a for loop. More examples of for loop is coming. For example, you have this set contains this apple, 4.9, cherry, and then you loop over the elements of the, as long as this x is in the set, print that. So first it will print apple, then it will print 4.9, then it will print cherry, and then it will, by the way, there's an else part in for loop as well. So if your loop completes its iterations, it never breaks due to some break statement or some condition that actually stops the loop being completing its iterations, then the else part will not execute. Else, there is an else part in for loop, and that says if the loop completes its iterations, there is no break statement that interrupts the loop iterations, then the else will then you will fall in the body of else once the loop has completed. Otherwise, you will skip that part and move on. Similarly, if you have a dictionary, for example, D is apple, the key is apple, and the value is 44. We saw dictionary and sets and everything in a previous video. So if you have apple, key is apple and the value is 44, the key is cherry and the value is game, for example, you can just iterate over this dictionary and print the values of it. So let's see this example of printing this dictionary onto using this Jupyter. So let's say we have D, a dictionary of, let's say, values. Key value is key value pair. The key is A, and the value is 1. And another key is B, and the value is 3. And another key may be a C, and the value is let's say value is game. So let's say that's a dictionary. Let's now iterate over the elements of dictionary. For x in D, print x, which is the key, and then the value D of x, and then after you're done, maybe you want to print that. So the key, which is x, is A, and the value is 1, which is this thing. Then the next element, then the next element, and then the next element. So you can iterate over a dictionary, iterate over a set, over a tuple, over a list, or anything. So this for loop condition x in a particular data structure, this is really handy in iterating over different kind of data structures. Okay, so I might be talking more about this loops and structure, but I've just given you very basic and important information to just get you going through this. Now I'm moving towards functions. A function basically is a complete. Maybe you're going to perform a particular task again and again. One way of doing that is you define that as a complete different module or function. Module is a different thing in Python. We will see modules as well, but a function is just a piece of code that you want to engage when you want that whole code. It may depend upon one line, it may depend a whole set of lines of codes, and it may achieve, normally these functions, they achieve a particular kind of task, and whenever you want to achieve that task, you basically invoke or call that function. So the syntax of defining a particular function is you first write def, which is define, then whatever name you think is suitable for your function, you write that name, then parenthesis, then this colon, like if and for loop, we write these colons at the end. Then the body of the function starts, like the body of if condition, body of loop, there is a body of function. Then you go inside the function, and whatever task you want to achieve, you write that and you're done. So let's write, let's just do one example of the function. So let's go here, type something, let's say define. My function name is print me, maybe, or print success message. Let's say that's the function. And then inside the function, I just say, okay, print successful. maybe, and that's it. If that's your function and you compile it, which means you basically you run it and you make all the symbol tables, then you can call that function like you're calling a print function, like you're calling other functions. For example, you can call whenever you want, you can call print success. And by the way, if you press tab, you will get this, and you go this, and it will print successful. And this body of the function can be very complicated task. Whenever you want, for example, this particular task to be achieved, you just call that function, you just write that function like this, and the whole task is executed, which is inside the body of the loop. And they become very, very handy in complicated tasks. You define different kind of tasks in different kind of functions, and the main caller function has actually different calls to that, different calls of different functions. The code become very, very readable, modular, manageable, editable, and I mean, this is very, very important in managing code as well. Another thing is that you can have a doc string. A doc string is just a string that actually defines the, if you want to know the help of that. For example, this function does nothing, let's say, and that is basically this is basically a string, sometimes called the documentation string or doc string, maybe of multiple may span on multiple lines, but this actually tells what the function is doing. Sometimes in complicated functions we need to write what is the function, what the function is doing, what input arguments that we will see later on, what input arguments it is receiving, what kind of output arguments it gives, and so on. And these kind of doc strings, they are helpful. For example, if you want to see what a particular function is doing, we can just write a question mark in front of that, and we will get to know what the function is doing. So you might be seeing the oh, they are saying there's no doc string. Why is that? Because we haven't compiled it. So let's, if you run this again, so that's the document string. If you are seeing here, the function does nothing. So that is kind of a description of the function, what it is doing, and it is important when you need help for the function and so on. Again, if you call the function, the doc string, because it is a comment, it will never be executed, but it will be available whenever you need to find out help about that function. Another statement that is important is help print. So that also gives you the help on this function, and in that help basically the doc string will appear, and that doc string basically describes your function. You can write a whole lot of description of your function, what the function is doing. Okay, so that was about doc string. Then we can have input arguments. Maybe we can send something that should be printed. So for example, in this particular function, we haven't passed anything to print. There was a fixed message that is going to be printed. We might have a function, for example, define print me, and it receives something that it should print. Now print. Here we are not writing a doc string. You should write the doc string message, and that's it. So now if we call that function print me and send anything, so it will print anything. Now you call that function again and send something else, it will print something else. Whatever it receives, that's the input argument. Whatever it receives, it will print that. Not just one argument, you can have several arguments. For example, define add x and y, and you just print x plus y. So now you call okay add 4, 5. So it will print 4, 5, the sum of 4, 5. And if you want that the result, if you want the result here, for example, you want a C that should have the result of addition of 4 plus 5, then you, rather than printing, you may want to return the value x plus y, and this return statement actually is used to return this, actually throw this value to this variable. So in this particular case, this, and the value is in C now. If we print C, we get 9. So this return statement is important. Return statement is not always required for returning a value. Sometimes you need to return from a function at a particular place. You just want to skip the rest of the function, like the break statement or something like so. In loops, there the return without these without this return value, return can also be used. But the most use of this return is for returning a particular value. If you don't want a print function, you want to use that function further. You want to use that value that the function is returning for your upcoming task. Okay, so that's about it. So next, we can have a whole lot of arguments. I mean, maybe you want to write an add function that if receives 2 values, it should add 2 values. If receives 4 values, it should add 4 values. If it receives 5 values, it should add 5 values. If it receives 5,000 values, it should add the 5,000 values in return. So in that case, the syntax is to write this star there, star args, and just pretend that this arg is acting like a list that is containing all the, so define add all, let's say that's the function name, and args, and now let's say s is your variable that is empty or containing 0 in the beginning for all x in args, s plus equals x, and then after this loop ends, you just return that value s, and you are done. So this kind of star operator, this actually receives arbitrary number of arguments. For example, if add all is called for 3, 4, it will return 7. And by the way, the return, I have not received the return value in a particular variable. The default variable is underscore. If you write this, underscore is default variable that is available in Python, but it's a good practice to receive the value in a particular variable. Further, if I send an arbitrary list, then it will add all these and will return a value. So this star operator sometimes becomes really important if your number of arguments, if the number of input arguments are arbitrary in length. And just consider this args like list. It is a list of arguments. Then we can have these functions with the names verifix, and we just call that state variables like this. I'm in C2, C1, C3, and we call C1 equals A. We just write C1, then C1 directly. So for example, here the first value is C2, that's our definition time. The second value is C1, but the third value is C3. But when we are calling the function, we are giving C1 equals A. That C1 will be received here rather than here, as long as this C1 is matching with this C1. Further, this C2 is B. This C2 will go directly here. Although here at the calling time it is at the second position, but as C2 and C2 they are matching, that will happen. Similarly, we can have this kind of dictionary list, this kind of I mean variable initial the function calling with these kind of state variables, and they can be arbitrary in length. And here we have just 1, 2, or 3. We can have so many of them, and then we can receive them just in double star, like the star contains input arguments that is just one thing. This contains the input arguments that act like a key value pair, like dictionary. So let's write code for this particular thing. And before writing the code, just think what it will do. X will be C1 for the first time. C is all. Consider this whole thing as a dictionary. I mean, the key is C1, the value is A. Key is C2, then the value is B. Key is C3, and the value is C. Then you are just iterating over this dictionary like you have done here, exactly here on the loop. So exactly this is going to happen. So let's go through this. Let's go through this on Jupyter. So let's define a function that contains that actually accepts this dictionary like arguments, and see what happens. Let's say define function. What was the name of the function? Like it can be any, but here I just write f star star c, and for x in c, print x as well as c of x. That's it. So this is, that's it. That's the function. So let's see what happens. We call that, now we call that function f, and let's say we give different arguments. Let's say c, let's say a equals a, and b equals b, and this can be an arbitrary lengthy list. Let's say d equals d, and z equals, let's say g, something like this, and it will print the keys and the values, I mean the variable names and their values. So this for loop becomes this for loop helps you iterating over this kind of dictionary, and this function, this double star, allows you to supply an arbitrary number of arguments if you need. One more thing about the functions, that if you for example define a function, let's say g, let's say, or func, or I mean g, let's say g is a function, and you have some variable, let's say t, and then you give a 0 to it, I mean, or some value. That means if somebody does not supply this value, then the 0 will be, by default the 0 will be given to that, and that is sometimes called the default values. For example, if I call g without any argument, without any input, then 0 will be printed. But if I give any argument, for example 10, then the 10 will be printed. So if I give an argument, then that argument will override. If I does not give, then this will act as a default argument. Further, you can define different functions in a particular file. If you go here, you can, for example, download this file or any file as a py file, which is a Python file. So if you go to this download, you can download this file as py file, and if the file contains a lot of functions, you can write that file somewhere in your computer and you can import that file. I've just written one file for you just to show you what a module is. So let me just go to, I have written the file, maybe I guess myfuncs, the name of the file is myfuncs. Okay, so I've written this file for you, and this file contains two functions. One function is print me, and it has a long doc string. Another function is print list, and it contains a list. The default list is empty. It contains a list and print the list. And I saved this file as py file, and I saved this file in a directory, and that directory where I saved this file is in the D drive. It is my modules and this myfuncs.py. Now what I can do is I can import these functions. These functions can stay in a different file, and I can use the functions whenever I need in these files by just importing the file, and at that time this file will act as a module. So this is how you import that file. So you first import the sys package, and then in sys is a system package, and then in the sys.path.append you just give the path of your module because it has to search, and then you can import just this py file excluding .py. You can just import that as anything and you can call that. Let me just try to do that. And by the way, this file is there, so let me just give you how can I do that. So So for example, import sys.path.append d my modules / my funcs, just this path. Okay, and then I can just import my funcs as any name, that's an alias, maybe as mf, and then let's see what happens if I do that. Now mf dot, if I press the tab key, these two functions are available to me that are there in certain files. So if I call this print list, and I don't know how to use it, so I can just call the docstring. The docstring is this function prints the list of elements. The input list is default empty, so I can just give the list of elements maybe. So list is simply, let's say 1, 2, and 1, 2, and 1, 3, and 5. Let's say that's the list, and if I print that, that function is called, which is no longer in this file. It is in a different file, and these are called modules. And the collection of several modules in a different directory structures, I mean nested directories and then nested directories, that kind of is called a package. Okay, so that's about modules. Now I've discussed this Python in a bit more detail, the very basics of Python, but there's much more to Python to be discussed that we have discussed in our comprehensive course, but I discussed the most important very basic things. Now I'm moving towards the three very common packages in data science. One is called NumPy, or some people call it numeric Python, and another is Pandas, and we will be having just for some minutes we will spend on Matplotlib, which is a plotting directory, which is a plotting package for plotting graphics. First of all, NumPy, they offer you arrays. So the question is, why NumPy? Because lists are there. There are other arrays as well. Well, the quick answer is NumPy is way faster. It is very fast. Actually, all the elements in this particular array are have the same type as contrast to the list. List can contain elements of different type. Having the same type gives it very good power and grip to apply a lot of functions very quickly. So whenever you have data that have elements of the same type, you should be considering NumPy, using NumPy rather than other arrays. They are very fast. You can import NumPy as NP. NP is an alias. You can have another name, and then whenever you want to use the features of NumPy, you can use those features using the NP. So let's just import this NumPy. Import, let's say NumPy as NP. That's it. We have imported that. So now the NumPy has been imported. Let's check the variant NumPy underscore variant, and the variant of NumPy that I'm using is 1.18.1. That's the NumPy variant. Now you can create an array. For example, a equals np dot array, and you can create an array in several ways. You can create an array with a list of numbers. For example, that's an array A. You can have another array B. For example, np dot array. You can have a tuple inside rather than a list. You can have a tuple 5, 7.3 and let's say 3. So these are two arrays. Let's check a dot d type, the data type, d type, the data type of the elements of A. All elements are integer of 32 bits. Let's check the data type of B, because one of the elements is no longer an integer. So let's check the data type. So b dot d type, that is float, and the reason is because one of the elements is float or a real number. The whole type is set to be a float. Further, if we want to, for example, add another element, for example, a want to change an element, for example a of, by the way, the indexing is like we saw the indexing in lists, the indexing in strings, the indexing is much similar here as well, although there is a fancy indexing here, we will see that, but indexing is much more like that. There are so many elements like a list, you can index those, and the index start from 0. So for example, the 0th element here is 1. If we do that this is immutable. The NP arrays are NumPy arrays are, sorry, the NumPy arrays are mutable. You can change the elements of those. So let's say we write 9.3 that. So and then we print the a. What happens is, although you have assigned 9.3, it actually just receives 9. And the reason is the type of a, if you remember D type, the data type, the type of a is integer 32. If you accidentally try to assign it a float value, the float value will be downcasted to integer, and you might not be knowing because the data type has been fixed. So this behavior should be known because it may cause certain problems. Okay, that's how you can create the arrays. There are other structures, for example, like data type. There is a number of dimensions. There is a shape variable. Let's see all these variables one by one. So so the other attributes, including the number of dimensions, which is this ndim, shape, and a couple of other attributes as well. So let's see all these attributes one by one, and also see what do we mean by number of dimensions. First of all, see this particular object, this thing. If you see that, that is one list, or can be considered one list or a one-dimensional array. If you have two one-dimensional arrays, two different one-dimensional arrays, and you have a list of those, then we call that kind of array as a two-dimensional. Further, you can see this is one-dimensional, this is one-dimensional. A list of those, list of two one-dimensional arrays or more than one one-dimensional arrays is a two-dimensional array. And this particular, let me change the color just to show that this particular thing here, this thing and that thing is showing a two-dimensional array. Similarly, you have a two-dimensional array here, and an array or a list of two-dimensional arrays is a three-dimensional array. So this ndim basically represents the number of dimensions of array. And we will see the shape as well. What do we mean by shape? Let's go to the Jupyter notebook and see what these what this ndim is basically. So for example, let's say we have a list, let's say 1, 2, 3, and let's say we have another list, maybe 5, 6, and 7, and let's say we have another list, maybe 1, 2, 3, let's say, or maybe 1, 2, 9, maybe. And now we have a list of these lists. So until now, this thing is a one-dimensional array. Each list is a one-dimensional array. Once you have array of arrays, that becomes a two-dimensional array. And if you have array of arrays of arrays, if you have this two-dimensional array and you have array of two-dimensional arrays, now that becomes a three-dimensional array. So for example, this, you may have different values, for example, -1, -3, and 15, and 70, and 20. Now these are two-dimensional arrays, and an array of this, an array of that is basically a three-dimensional array. Now if you make an array, let's say C equals np.array and array of this 3D list, then you will create an array, and the ndim basically will be 3 because there's 3 dimensions. Further, the shape of this structure is 2 by 3 by 3. Why this is 2 by 3 by 3? And the reason is you have two arrays, each of which is two-dimensional. So you have two two-dimensional arrays, and each array has each array is a 3 by 3 two-dimensional array. So what I want to say is that you have two structures of this kind. This is one structure. This is a one two-dimensional array. You have two such structures, so you have two of them. Now if we go inside each structure, let's say in this structure, then you have in this one structure, for example, you have three lists. So these are the three lists. So that is this number 3. Now if we go to in these three lists, if we go to any one of those, for example this one, then you have 3 numbers. So that is this 3. So what do you think? What will be, so this, we can have this C dot shape 0, and that will return the shape in the very first axis, which is 2. We can have shape 1 with this will return the second number. We can have this shape 2, and that will return the third number. So this is what this shape is. Now to access this multi-dimensional array, let's say C, and we index it, let's say 0, 1, 2. So let's see what is printed. So first of all, 0, C of 0. We have two such structures. This is indexed at 0. This is indexed at 1. So first 0 will choose one of these two-dimensional arrays, one of the two-dimensional arrays. So this is chosen because the index is 0. Then we move to 1. 1 means in this two-dimensional array, which list is going to be chosen. This list is at 0, this list is at 1, this list is at 2. So this will be chosen, this thing, 5, 6, and 7. So once we are in this list, then the third number will operate. In this list, the index 2 should be output, and the index 2 is 7. Because index 0 is 5, index 1 is 6, and index 2 is 7. So 7 will be the output, and that's the output here. Yeah, great. So further, we can index or we can slice NumPy arrays like we can slice the lists. Again, here is a start index, end, and a step. If start is not supplied, it is assumed to be 0. If end is not supplied, it is assumed to be the length of the list, length of the array. If step is not supplied, it is assumed to be 1. Just one thing, remember, if the end value is given, it is not included as an index. So for example, if A is a NumPy array, and then index 1 colon 5 means start from 1, take the step of 1 and move till 5, but not include 5. So it will include the indices 1, 2, 3, and 4. So then if we do not supply the start value, it is assumed to be 0. So start from 0, go till 5, but do not include 5. Again, even if we write 0 here, even if we write 0 here, for example, even if we write 0 here, the above statement and this statement are exactly the same. So we do not write 0, it is assumed by default 0. If we write 0 and start from 0, go till 5, these two are exactly the same things. Then start from index number 2 and go till end, but include the last value. So these are kind of the slicings that we saw in lists and strings as well. Negative indices are also there. One trick to reverse the array is to give the negative index. And in this, magically, just what happens is this start and end, they just get swapped. So you start from the end, you take the step of -1 and move backwards. What it does is it will actually reverse the one-dimensional array. If you start from the very beginning, if you want to go to end, but you take the step of 2, so you are skipping one element and picking every other element one by one. And this is a quiz question for you. What will this do if A is a two-dimensional array? What will this do? Yeah. So let's play with some of these indices on Jupyter. Let's say, okay, A is np dot range. That's an np dot range is just a function. It actually gives let's say these are the numbers. It actually gives the numbers between 0 and 10, but not including 10. So that is just I mean the sorted numbers. We can have unsorted numbers as well. So that's A. So what do you think? What will be A minus 2? What will be that? What do you think? So -1 is 9. -2 is 8. So this will be 8. Yes. So what will be what if I say, okay, 2 till 6? So index number 2 is this, index number 6 is this, but 6 will not be included. So 2, 3, 4, and 5, that will be printed. So that's 2, 3, 4, and 5. Yeah. So now if I want to reverse that array, I will just go and say, okay, -1, and the array will be reversed. 9, 8, 7, as we discussed earlier. If I want to pick every second element, we'll just go to that, and every other element starting from the very first element will be picked. So we can have much more indexing. I mean, the indexing or slicing, this is called slicing. And there are more indexing, sometimes called the fancy indexing. The NumPy allows you to give array as an index rather than just giving slice. You can just give the indices that you're interested in. For example, if I want to pick index number 2, index number 3, and index number 7, and I just want these elements to be picked. So index number 2 is 2, index number 3 is 3, index number 7 is 7. It is available. If I want index number 4 first, then first index number 4, then index number 1, then index number 9, then these will be picked. By the way, here maybe you're thinking that the indices are just getting printed out. So let me just take an A as np.arrange and then just permute them. So this is, let's say, 10, and let me just permute them by using np.random.permutation. So this will permute all these numbers and give me A. So A is now this. A is some permutation, some reordering of all these numbers. So A, for example, now you will get a better look and feel of that. 2, 5, and 7. I need the value at index 2, the value at index 5, and the value at index 7. Not only that, for example, I can give it in a list of, for example, a list of true, false, true, true, false, true, false, true. How many are these? I need 10 of them. 1, 2, 3, 4, 5, 6, 7, 8. We have 2 more left. So false, false, and it will return me all the elements where the true is there. So for example, the first element will be returned, third will be returned, fourth will be returned, this one will be returned. So wherever there is true, those elements are returned, and this allows us. So for example, if I just apply this 4, what it does is this a smaller than 4 will return a boolean array of this kind. So whatever elements that is smaller than 4, at that place we have true, otherwise we have false, and then we can index. Then we can use that boolean array as index and just pick the elements from A, and those elements will be there. So all elements that are smaller than 4, they are there. One thing that if you use array indices, this or that, you will get a copy. You will get a deep copy, a separate, the return value is a deep copy. On the other hand, if you use slice, you will get a view, a different view, which means the actual array is the same thing and you are just getting a different handle of it. So if you change the value in the view, if you do slicing and you receive a value in another variable, and if you change any element in that variable, you get the actual array changed. However, if you do the index array, if you use index array or the logical array, either way, you get a copy rather than a view. So that is important. Okay, here is one question for you, just as a quiz, or I mean just to think on. What is the difference between AND operator and this AND keyword? So for example, if I make this array as all the elements that are smaller than 8 and larger than 4, what if I use the if I use this and if I use this a and the and, which one is correct in this particular scenario, and why is that? So that's a question for you. Just think about it. Because and is a keyword, it has same kind of feeling. This ampersand, this character is also used for and. Can I use a and the and here, or this one? Which one is correct? Are both of these correct? And if one of them is correct, then why is that correct, and what is the difference between a and the and this particular character? That's a question for you. Just think about it. Okay, so the universal functions, the functions that the NumPy offers, are way faster than the functions that are not in NumPy. If you apply the functions that are not in NumPy, and if the function is available in NumPy and you use another function that is not in NumPy, probably you will be getting much slower. An example of this is just this script. Let me just go through this example. So let me make a very big array. How many zeros are there? 1, 2, 3, 4, 5, 6 zeros. So let me make an array. Let's say a is np dot random dot what rand np dot random dot rand. Let's say that's a big array. Let's say I do that. Now I want to add all the elements in that array, and I want to see what's the time it takes. So np dot sum a. So what time it takes? It takes, for example, time it. Let me call time it. That's more stable. Time it. That's a magic function. Time it. It will tell that the summing an array of this size will take how much time. It is giving 2.61 millisecond with a particular standard deviation and stuff. It actually does the operation again and again and just returns the average. What if? And by the way, you can add all elements using a.sum as well. I mean, and these two are exactly the same things. Damn it. So the time is roughly the same. I mean, if you run it again and again, whether you call np.sum or a.sum, they are same. Whichever is more readable to you, that's okay. But on the other hand, if you use a function sum that is built in Python, that is for lists and for everything, and you just apply that onto a NumPy array, let's see how much time will it take. Oh, it's huge. I mean, that's 342 milliseconds, and compare it with 2.61, or let's say 3 milliseconds. Where are the 3 milliseconds? Where are 342 milliseconds? Huge difference. If you attempt to write your own code, let's say s is equal to 0 for x in a, s plus equals x, and you just want to see that if you write your code to sum that up, how much time that it will take. By the way, to compute the time for a cell, you have to write this double, this percentage sign, time it. So let's see how much time your function will take. That's almost the same as the sum function. So the built-in functions in NumPy, which is called the universal functions, they are way faster. Whenever available, you should use those. You should never use loop. Whenever avoidable, avoid the loop. NumPy is optimized. If you use its own function, it uses vectorized implementation that is much faster than otherwise. So I will recommend, whenever you are using NumPy, avoid loop to the best level you can. If something is unavoidable, it is unavoidable. But if it is avoidable, spend some time on it. Do some logic, do some tricks, use built-in functions, use the universal functions. Universal functions like np dot or the array object dot functions, and they'll be there. They are much faster. Okay, there's more to speak about NumPy, but in this just short tutorial, I wanted to just discuss the very basics and the important things. Let's move to Pandas. Pandas, like NumPy arrays, Pandas is basically I mean, you'll be much fluent if you want to use the data that has heterogeneous type. I mean, some of them are strings, some of them are kind of floating point numbers, some of them are like, I mean, the very mix of data, and the data is in a tabular form having headings and indices and stuff like that, then Panda is much better than NumPy. Although Panda is built on top of the NumPy. I mean, all the things that you have enjoyed in NumPy, Panda is built up on that. So Panda has two basic, although there are three most prominent objects, but the most important or useful are series object and data frame. There is another index object as well. So let's see what's the difference between NumPy array and a Panda data object or array. Let's see. Pandas. So first of all, import pandas as PD. Let's say that's the name. You can check the you can check its variant, print PD dot variant. The variant I'm using is 0.24.2. Then you can use data array. Let's say D data equals PD dot series. Yeah, series, and it contains two kind of things: the index and the data. So the data is maybe, let's say, 3.4, 3.4, 5, and 6, and the indices are, let's say, index array is basically A, B, and C. So the data is available. If you print this data, you get the indices, like rather than the indices 0, 1, and 2, you have now indices A, B, and C, just like the dictionary. You can now access all these elements using their indices. Like A, the value is there, 3.4. You can change that value. This is mutable, so changeable. You can change that value to, let's say a value, let's say 7, and your data will become 7. So series is about, I mean, one-dimensional array. You can slice it just like you're slicing the NumPy array. I mean, all the indexing that works there in NumPy works almost the same in Pandas, with one thing that sometimes you have to use the implicit indices and sometimes you have to use the explicit indices. If you call this data.values, it returns all these numbers. If you call data.index, it will return all these indices. Further, you can have a dictionary. For example, this is a dictionary with A as a key value, 4 as a number, A minus as a key value, 3.5 as a number, and all that dictionary. And then you can create just grades object using that dictionary. And you may have another dictionary, for example, of marks, and you can create a series object on that. And then data frame basically is more than one-dimensional array with, again, the same kind of look and feel that you have. For example, multiple dictionaries, and your multiple dictionaries, you're concatenating them together. And data frame is basically the dimension up variant of series. So let's see, for example, let's just code this. Let's say you have an object. Let's say you have an object grades. Let's say that is PD dot series. So let's say you have a dictionary inside. Let's say the dictionary objects are A is 4, B is, let's say 3.5, or let's say A minus is, let's say 3.5, and let's say you have another index, let's say C, and C is, let's say just 2. That's an object. And let's say another series object, let's say marks, that is again PD dot series, and you have, let's say A, the marks should be 85 to get an A grade, to get an A minus grade, let's say the marks should be a 75, just thinking. And then to get a C grade, the marks may be 50 out of 40. Let's say that. And now both are these series objects, like the data object and drop you are seeing. Now let's say build another object, let's say B, which is the pd.data frame. Data frame, and data frame accepts both these series objects as let's say grades. Grades, that's also a dictionary, that also accepts like a dictionary. I mean, grades as grades, and marks as marks. And after this, if you see B will be a much nicer form than the series object. It says grade, it's marks, and so on. Further, you can access these grades column, and you'll be available with a grade column with certain data types inside. You can index it using B. You can see the values B dot values, and that will just be a two-dimensional array of the data inside, and you can have that, and you can play much about with this data frame. And normally when we read different kind of data files, this is the data frame object that is mostly much more powerful. You can add more. For example, you can add another column. Let's say we are going to add another column, percentage. Let's say we add another column B. It's very simple to add another column. Let's say percentage, and let's say that is B. Just think that is just marks divided by 100, and a new column will be added here. You can see another column, percentage, is added. Further functions, I mean many more functions in this B is B dot describe. If you call that function, it actually tells us a lot about whole data. The total count of grades are 3, the total count of marks are 3, the percentage is this and that, the minimum value is this, the standard deviation is this, the maximum value. I mean, this describes much more statistics about B. We can transpose the B. We can flip the view. I mean, these indices, they go there, and these columns, they become there. I mean, a lot to play with it. And further, indexing in Pandas using a series object or a data frame object. It is, for example, you may declare a series object with values A, B, and C, and then you have indices, for example, 1, 3, and 5. So now this one is index that you are defining, that is index is there. Or you may be using, I mean, when you write data 1, are you going to define this particular index, or you are going to define the implicit index? There are implicit indices as well. The implicit index of A is 0, the implicit index of B is 1, the implicit index of C is 2. But the explicit index that we are assigning is 1 for A, 3 for B, 5 for C. Now, if you call like this, the explicit index will be called. But if you use the slicing operator, the implicit index is called. Now, this is sometimes confusing. Whether if you use slicing, always the implicit index will be called in this particular way, if the numeric indexing is used. If we don't use slicing, then the explicit will be called, and sometimes the confusion may occur. So to resolve that confusion, there are two functions, LOC location and index location, ILOC. If you call LOC, that means the explicit index. So for example, data frame ILOC 2, 3, that means second row and third column using the indices, the implicit indices. If, however, I use the LOC function other than I, that means whatever the explicit indices, they will be referred to. Okay, Pandas is best for CSV files. If you have CSV files, for example, if I show you in some other tutorial, I have used this coronavirus dataset file, and I use that file just to analyze a lot of things using these pandas. Just some of these things. Let me show you some of these things. So this is the COVID-19 file. Let me open up that file for you. So this is the file. I mean, this is telling the when the patient was observed, what was the province, what was the country, at that I mean, in that country, in that province, how many confirmed are there, how many deaths are there, how many recovered are there on different dates. And this is the data for different dates, I mean, till the 14th March. If I read this data in for example Jupyter, I just have to import pandas, NumPy, and just to handle the NaN entries, the not a number entries or the missing entries, I'm using this Scikit-learn package imputer, and then I have to call pd.readcsv, and whatever that file name is, covid19.data.csv, and then this single quote and this, and the data will be read. Then I have this data frame is in df. Then I have a lot of these functions. For example, I can drop different serial number is not required, last update is not required. I can drop these columns and they will be dropped. When I have in place true, that means the drop should happen inside the word, inside the object, and the object actually get changed. I can rename different column names. For example, the observation date can be renamed by date. That's a dictionary object, the famous. The province / stat can be renamed by stat, and so on. Again, this is in place. The date object is no longer in a formal pandas date, so I can convert it to pandas to daytime. Similarly, I can handle all the missing entries using a simple imputer from Scikit-learn. That is again a data science package, basically machine learning package. I can group different. I can rearrange all the data I can group them by date and then country. I can group them by country or date, and I can view all the data in different ways. I'll be posting this file along with this code at AI Sciences, the link at AI Sciences. So you should be playing with this code. I mean, I will encourage you to just write this code and then call this function and see what happens. That will be, I mean, in very, very easy ways, you'll be handling CSV files and very large data files and very few lines of codes. You will be cleaning your data and stuff and so on. So it's very, very good with files handling and data munging and a lot of stuff. Okay, the last module of this code is this video is the Matplotlib, which is the library for visualization. I mean, the graphs and different stuff. I will briefly go over Matplotlib very quickly. So first of all, you go and you import the Matplotlib package. The most important thing is pyplot. So import matplotlib.pyplot as plt. So this plt is just a, and now then you can simply just go and see, okay, np.linspace. So x is np.linspace. Start from 0, go till 10, and make 100 points, and then just plt.plot x comma whatever, x plus 3, for example, and plot it, and you will be seeing a plot right away. Oh my god, I mean, that simple. You're seeing a plot that simple, very, very quickly. And there are so many ways of plotting. I mean, I have plot that simple. You can call sine function, for example, plot this plt.plot x np dot sine x, and you can plot plt dot plot x dot np dot cos x, and on the same plot you can plot plt dot plot x and x plus 5 maybe, and see what happens. Well, these plots are there. I mean, these plots are there. If you just skip this thing, you will be seeing things in a proper scale. For example, this is the sine x plot and the cos x plots. We can add legends, we can add labels, we can add titles. I mean, there's so much support in there. We can go and do that. There are color support, for example, green color and cyan color and black color and the red color. We can have a solid, we can have a dashed graph, we can have a dash and dot graph, we can just have a dotted graph. We can specify color in several different ways. We can have grids, we can have meshes, we can have 3D plots, we can have plots on a globe. I mean, a lot of and many times we want to visualize our data, we want to visualize different attributes of the data, and one better way is to visualize a pair of attributes is just to plot and see the relationships, their correlations and stuff. And this Matplotlib is really easy and very quick and very powerful. So I end here. I end this video here. The more detailed discussion on all of these topics that you have gone through is available on our comprehensive course on AI sciences. If you have liked this video, just subscribe to our channel, share it with others, press the notification button so that you can receive more valuable videos from AI sciences. So I thank you all. Good luck with that.